I am assuming that everybody can see this all right. Okay, well, with that, thank you so much, John. And I want to thank you all for coming to this presentation tonight. So for my thesis, I evaluated the methodology of the Fish and Wildlife's Coastal Nearshore Rod and Reel Survey, which was initiated in 2019. And I was looking at its ability to detect black rockfish population abundance changes. So the reason that I chose this topic was because an evaluation was needed, essentially, to help both state and federal fisheries managers decide if this survey can be used in the upcoming black rockfish stock assessment. Like Johnson, I do currently work as an employee for Fish and Wildlife, but I did not design or conduct any of the surveys or the pilot studies that I used for this thesis work. All right, so let's get going. I'm going to talk to you tonight a little bit about black rockfish biology and then how they are managed in Washington State. I'm going to go over the rod and reel survey design, and then I'm going to talk to you about the questions that I wanted to answer through this thesis work. I'm just going to talk to you about some of the pilot studies and some of the data analysis, and then the conclusions that I can draw. So black rockfish are a semi-pelagic schooling species that range all the way from Alaska down to Southern California. They're generally found above rocky reefs in waters less than about 240 feet deep, which means they're one of our nearshore species. As juveniles, they tend to eat zooplankton, so amphipods and copepods. And as they grow and become more tightly associated with the bottom, their prey kind of diversifies, and they rely on other crustaceans like shrimp, also octopuses and other fish, and even other rockfish species. We think that they live about 56 years and they grow to about 13 pounds. Like all Sebastes, they do give birth to live young, and we think they do this about 6 to 8 years of age. So these fish really contribute to the diversity of the nearshore ecosystem, and they also support a very popular recreational fishery, which means that they need to be managed. So working through the Pacific Fisheries Management Council process, which I'm not going to go into here, it's all in my thesis document, but state fisheries managers at the Department of Fish and Wildlife, they set annual harvest limits for black rockfish. So this management process is informed by survey data, which is used in assessment models, and without this reliable data to inform stock status, harvest limits might be unsuitable for maintaining sustainable fisheries. So for black rockfish off the Washington coast, it was last fully assessed in 2015. So despite not having kind of a really updated stock status, there are still annual harvest guidelines that managers must hold the fishery to. In Washington, there is no direct commercial harvest, and they did that because they wanted to allow more recreational take. The recreational fishery is very popular, and over the past 5 years or so, the recreational fleet took on average 281 metric tons per year. So just for some context, the harvest guideline for this year, 2022, is about 273 metric tons. So this fishery is fully utilized, which means that it needs to be limited. And the fishery is currently limited through bag limits, or how many fish you can take per day, and seasonal restrictions to help keep harvest within these annual harvest guidelines. So during the last black rockfish stock assessment review, some concerns were raised about the lack of a fishery independent survey to help inform stock assessments for multiple bottomfish species off the Washington coast. So the Department of Fish and Wildlife implemented a coastal rod and reel survey in 2019. However, that survey has not been evaluated to determine if it can detect abundance changes specifically in black rockfish populations. So let's look really briefly about how that survey is conducted. It's a nearshore survey using rod and reel gear. The survey occurs in spring, so that's March through May, and they sample at 125 index stations, which are distributed along the coast. It uses 5 anglers. And these anglers all use standardized rods and reels with 2 shrimp flies on a pre-tied leader above a dropper weight. And this is important to note because I'm going to talk about the types of bait that we're using. So at each index station, it is drifted over 4 times with fishing time recorded by each angler. And you can kind of see a stopwatch here in the front. So each angler records their time per drift. Okay, so for this thesis work, data from various pilot studies, also information from published literature, And data from the WDFW Black Rockfish tagging program were used to evaluate the survey's design and to determine the effects of multiple things. So first, what I wanted to look at was location. I wanted to know, are abundance indices derived from sampling at rod and reel survey index stations representative of the Washington coastal black rockfish population? I also wanted to know, does the survey use terminal tackle or bait and sampling gear that's appropriate to consistently capture this semi-pelagic species? I wanted to know, does the survey sample at a suitable time of year? And is the survey effort sufficient to detect changes in population abundance using catch per unit effort estimates? Okay, so first let's talk about location. The 2015 stock assessment used fish release data from the Black Rockfish tagging program, which was from 1986 to 2014. That's the data set that they used, to create an abundance indices that was used in a stock synthesis model. So the gray dots on this map represent the locations of those surveys in catch record area 2, which is kind of central coast, that occurred in the spring months, which was considered February to July for the assessment authors. So what I wanted to know is, if you only use surveys at index stations, would you see the same abundance trends when you compared it to all the surveys that were done in the area? So to do this, I mapped all of the index stations. Those are the green dots here on this map, although you can't see most of them because they're covered up by other dots, but there are 66 of them. And whatever surveys fell within 500 meters, within a buffer of 500 meters of an index station, was identified. And those can be seen as these orange dots on the map. So when I looked at these surveys that had been identified that are near my index stations, the ones prior to 1998 were pretty sparse at index stations, and there were some significant changes to the tagging program that occurred that year. So for the comparisons that I wanted to do, my data set was from 1998 to 2014. So essentially, of the original 1,268 surveys, I used 400 of them to calculate an abundance indices from the index stations. Okay, so what did that show? The results from this analysis showed that the two abundance indices actually followed the same general trends over time. On this graph here, the y-axis is catch per unit effort, and the x-axis is time. Now, you can see that there is a lower estimate in 2014. And I was talking to the folks at Fish and Wildlife to see why this might be, and it may be attributed to some of the changes in the survey design that year, because they expanded their effort to a lot of additional areas along the coast. So despite these abundance indices being very similar, I thought that managers would also want to know if the indices calculated from these index stations made large changes to the stock assessment model. So the 2015 stock assessment used stock synthesis, and that is what I used here to run 4 different models. The dark blue line is the original model run by stock assessment authors, and the triangle with the light blue is that same exact model, but I truncated it to only the years 1998 to 2014. I also removed all the length composition data. The yellow line is the indices that have been replaced, and these are the indices from our index stations from the years 1998 to 2014. And I also wanted to see what is going to happen to this model if I took those indices out altogether, and that's the red line. So as you can see, there was very little practical changes to the model based on changes to these indices. In fact, leaving the indices out altogether had a very small effect on the model. This may be due to the fact that the assessment authors added variation to this indices because they weren't fitting some of the other sources of data very well. There's some other explanations to this, which are in my document that I don't really have time to go into here. But because the abundance indices trends were very similar and the changes to the stock assessment model were very low, I can conclude that the surveys conducted at the index stations show the same abundance trends as surveys conducted at all locations in the area, and that these index stations can be representative of the adult black rockfish population. I also wanted to see if the bait type designated for sampling during the survey optimally and consistently captured black rockfish. So WDFW did a pilot study in 2014 and 15 to evaluate different types of terminal tackle or bait type for different types of targeted bottom fish. So analysis of this data specifically for black rockfish showed that shrimp flies were able to capture more black rockfish per angler minute than other bait types that they tested in 2015. And in 2014, shrimp flies were definitely preferred by the anglers because they thought that they caught more fish, but I was not able to statistically analyze that data set. So through this analysis, I can conclude that shrimp flies are appropriate for consistently capturing black rockfish. There are some questions about gear saturations and sampling effort, and those are addressed in the document. Gear type was also considered during my thesis work, and fortunately, Fish and Wildlife had already looked into this question for me. They did a pilot study of set line versus rod and reel gear types, and they concluded that black rockfish were more efficiently caught with rod and reel gear. On this graph here, you can see on the left-hand side, this is black rockfish called out. And please note that the scale on the left side of the map is different than the scale for the other species. So this work informed the decision to use rod and reel gear for the 2019 survey, and I concur with this gear type. This is also the same gear type that they use in California for their nearshore survey, and that data is also currently being used in stock assessments. Additionally, there was a cost analysis done for the pilot study that showed for this 5-day comparison study, the rod and reel gear cost about $13,000, while the set line efforts were about $36,000. So rod and reel not only caught more black rockfish, but the survey itself was significantly cheaper to conduct. Okay, so now let's talk about timing of the survey. Based on communication with WDFW managers, survey timing was primarily based on 3 factors. The first was charter vessel availability, the second was the weather conditions, and the third was cost. However, fortunately, a pilot study had also been done, and it was conducted, fortunately, in the spring and in the fall months at 10 locations over 3 years. So I analyzed that data for black rockfish, and I found that there was no statistically significant difference in catch per unit effort of black rockfish in the spring, which is March through May, or in the fall, which is August through October. So based on the results from the pilot study, I can conclude that spring is an appropriate time frame for surveying adult black rockfish. And then finally, I want to talk a little bit about effort. So I did a power analysis to evaluate the risk of making a type 2 error. And as we all know, but just for to bring it to the front of your mind, it's the failure to reject the null hypothesis when it is in fact false. So I found that the power of the hypothesis test to detect a difference of 0.05 in catch per unit effort was 89% using 4 drifts across the station. And this is what they used in the rod and reel survey. This table also shows additional power analysis for the detection of different effect sizes based on information from 3 drifts across the station and 4 drifts across the station. Analysis for this was done based on the 2019 and 2021 rod and reel survey data. I couldn't use the information from 2020 because the survey was not complete because of the pandemic. But I can conclude that sampling at each of the 125 index stations with 4 drifts per station was adequate for detecting changes in black rockfish population abundance. So I know that that was pretty quick and dirty, but the conclusions are that this comprehensive evaluation affirms that the WDFW Coastal Rod and Reel Survey can produce representative abundance indices, and that they can be utilized by managers and incorporated into Washington's black rockfish stock assessment models. So with that, I would like to acknowledge all of these folks and the Department of Fish and Wildlife for their support and the data for this thesis. And I'm going to leave it on the slide because there's a lot of folks on here that I would like you to read. But with that, I will ask if there are any questions.